Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to find and verify inverses of rational functions. The instructions for the example that we're about to do is as follows. We have to find the inverse of the given function and verify that it is the inverse algebraically by composition. Okay, so the example that we're looking at is as follows. We have the function f of x equals 2x plus 1 divided by x minus 2. Alright, so let's go ahead and get started. This problem is going to be a three-part process. We're going to start off by finding the inverse function. Okay, so part 1, we're going to find the inverse function f inverse of x. Okay, let's go ahead and do that. Now, we have the original function, which is f of x equals 2x plus 1 over x minus 2. Now, to find the inverse, we're going to do a switch. Okay, we're going to replace the output variable with the input, and then the input with the inverse of the output variable. Okay, so f of x will become, let's color code it, f of x becomes x, and then equals 2. Instead of x, we have the inverse of f inverse of x plus 1, that divided by the x again is converted into f inverse of x minus 2. Okay, so we've carried out the switch step. Now what we're going to do is we're going to solve. What are we solving for? We're solving for the inverse of f, and that will be the inverse. Okay, to accomplish that, we're going to first cross multiply, and then we're going to collect all the terms with the inverse of f on one side, everything else goes on the other. We'll factor out the inverse of f, divide, and that will result in the isolation of f inverse. Alright, so let's go ahead and cross multiply. The bottom left goes to the top right, the bottom right goes to the top left, and we have x times the inverse of f minus 2 equals 2 times the inverse of f plus 1. Alright, so we're going to distribute on the left side. If we distribute, we have x times the inverse of f minus 2x equals 2 times the inverse of f plus 1. Now, to get f inverse isolated, we have to collect the f inverse terms. Okay, so 2f inverse of x and xf inverse of x need to be collected to the left side. So to accomplish that, we're going to subtract 2f inverse from both sides of the equation. And then we need negative 2x on the right side of the equation, so we're going to proceed to add 2x to both sides of the equation. Now, what's the result of this algebraic manipulation? On the left side, we are going to have x f inverse of x minus 2 f inverse of x minus 2x plus 2x, they both add up to 0. And then on the right side, we have 2f inverse minus 2f inverse. Those ones add up to 0. Also, 1 plus 2x, we just have 1 plus 2x. Now to get the inverse of f isolated, we will proceed to divide both, well, we'll factor out the f inverse first. So let's factor that out. Factor out f inverse of x. We're left with x minus 2 equals 1 plus 2x. And then we'll proceed to divide both sides by x minus 2. Okay? And that will result in our inverse of f, which is 1 plus 2x over x minus 2. Alright, so is this answer correct? We're going to verify by composition. Okay, so let's go ahead and do that. So part 1 of our composition is part 2 of the entire process. So for part 2, we're going to answer the question, is f inverse, no, is f composed with f inverse, is this equal to x? That's the question. Okay? So let's talk about the formula for this notation real quick. So f composed with f inverse of x, this simply means that you take, so what f composed with f inverse of x means is basically you take f inverse and you plug it into f. Okay, so f composed with f inverse of x. Alright, so to carry out this composition, we're going to start off by writing down what the outer function is. The outer function is what we started with, f of x equals 2x plus 1 over x minus 2. And then we're now going to proceed to get the outer function prepped, because we're going to be putting the inner function in it. Okay, basically substituting all the x's with the inverse function that we got in part 1. So let's clear out all the x's to make room for the incoming input function, which is the inverse. Alright, so this is f of x without the x's, so we're going to input the inverse, which is 1 plus 2x over x minus 2. So the name of the input function is f inverse of x. And then we're going to put in 1 plus 2x over x minus 2. And then 1 plus 2x over x minus 2. Okay. Now we're going to go ahead and simplify this complex fraction that we have here. Now this 2, imagine as though it's a fraction, 2 over 1, and we can distribute it into this quantity right here. So 2 goes into the numerator and 1 goes into the denominator. When we multiply, we are going to have 2 plus 4x divided by x minus 2 plus 1. And the denominator remains the same. There isn't any coefficient in front of the parentheses to distribute into the quantity. So we just have 1 plus 2x over x minus 2. Now how do we convert this complex fraction into a simple fraction? To accomplish this, all you just have to do is find the LCD of all the denominators, multiply your numerator and denominator by that LCD, and that will accomplish the simplification of this complex fraction. So 2 has a denominator of 1, 1 has a denominator of 1. The LCD of x minus 2 and 1 is x minus 2. So we're going to proceed to multiply every single term by x minus 2. Okay, so this will multiply by x minus 2. And then we'll multiply this by x minus 2. Multiply this by x minus 2. And then we'll multiply this also by x minus 2. Let's go ahead and simplify. Observe how this complex fraction becomes a simple fraction. We now have on the left side of the minus in the numerator, these x minus 2's divide out. So that leaves us with 2 plus 4x. And then 1 is a multiplicative identity, so we just have plus x minus 2. When you distribute 1 to the quantity x minus 2, nothing changes. In the denominator, You see the cancellation action happening here also. X minus 2 divides with that. So we have 1 plus 2x. And then minus 2 gets distributed. So when you distribute minus 2, you have minus 2x. And don't forget the negative when distributing, okay? When you multiply negative 2 by negative 2, you get positive 4. Now let's reduce further. 2 minus 2 adds up to 0. And then the denominator 2x minus 2x adds up to 0. So we're left with 5x over 5. 5x over 5 reduces to x. And that's the desired outcome that we want. Now we have one more part to execute. Part 3 just involves the reverse composition of what we just did. So in part 2 we said is f composed with f of x, and we found out that it is. Now what we're going to do is answer the following question in part 3, which is the inverse composed with f, is that equal to x? That's the second question that we have to address. Okay? If this is true, then we have shown that our inverse is in fact correct. So to accomplish this, we're going to start off by writing down the formula. What does f inverse circle f mean? Let's break that down. F inverse composed with f of x just simply means you're going to take the inverse function as a parent and input f of x as an inner function. Alrighty, let's do it. The inverse function or the inner function f inverse of x is equal to 1 plus 2x over x minus 2. Alright, so we're now going to get the inverse function prepped for composition. To do that, we just take out the x's and replace it with parentheses. Divided by parentheses minus 2. Alright, so the name of the input function is f of x. Okay, and the value is 2x plus 1 over x minus 2. 2x plus 1 over x minus 2. Okay, that was the original problem. Now, one thing you notice when you're executing these steps is that there's a great similarity between parts 2 and 3. Okay, so you can use part 2 to basically guide your problem solving process in part 3. So if you notice what we did in part 2 is we distributed this 2 into the quantity in the parentheses. That's exactly what we're going to be doing here. You can express 2 as 2 over 1 and then just distribute it to 2x plus 1. Alright, so just distribute. When you distribute, you end up with 1 plus, let's write that again. We have 1 plus, distribute the 2, 4x plus 2 divided by x minus 2. And then in the denominator, we have nothing to distribute, just like part 2. So we're left with 2x plus 1 over x minus 2 minus 2. So we're confronted with the same problem that we faced in part 2, which is we have a complex fraction scenario that we want to simplify. So to do that, we are going to express it as everything as a fraction and then find an LCD of all the denominators. Okay? LCD of all the denominators here is x minus 2 again, so we just simply multiply everything by x minus 2. So x minus 2, x minus 2, x minus 2, and then also this one times by x minus 2. Alright, now we're now going to proceed to simplify that when we simplify, the following happens. On the right, this x minus 2 divides out, and you distribute the 1, you have x minus 2 plus 4x plus 2 in the numerator, and then in the denominator we have what do we have in the denominator? You see the cancellation happening. X minus 2's divide out, and then we have 2x plus 1, and then when you divide this negative 2 to x minus 2, you have minus 2x plus 4. Okay, in the numerator the 2's are inverses, so they add up to 0. In the denominator, the 2x's are inverses, they add up to 0. So that leaves us with 5x over 1 plus 4, 5, and that comes out to x, which is what we desired. Alright, so let's go ahead and write down our conclusion. Our conclusion is as follows. Since f of x, the answer we got, which is 1 plus 2x minus 2. Well, let's just restate that. So since what we did is we composed. Okay, so since the forward and backwards composition, since f composed with f inverse is equal to f inverse composed with f, since these are both equal to x, then the function we got as an inverse function, 1 plus 2x over x minus 2, is the inverse of the original function, which is 2x plus 1 over x minus 2. Alright, and we'll put a nice little box of accomplishment. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of inverses and verification, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other tutorials such as this. If you have any questions or comments, just place it in the comment section below and we'll be more than glad to respond. More clips and support resources can be found at mathgotserved.com. Go ahead and check it out. Thanks again for watching and have a wonderful day. Goodbye.